Okay. Now, can you see?
No, ma'am. Recording on होते हैं.
Hmm. Okay. Now you can see.
Yes, ma'am.
Yes, ma'am.
Okay. Everybody can see the screen now.
Yes,
Yes,
ma'am.
ma'am.
Okay. Uh, so once again, I'm going to explain the quantum yield. Quantum yield is the term which involves in the photochemical reaction. When, when we have a photochemical reaction, it means that all the reactions, they are induced by any source of light in terms of photons. These reactions are called as photochemical reaction. Now, the meaning of quantum yield we can understand in terms of like we have a simple chemical reactions, like when we have 1 mole of reactant which gets converted into 1 mole of product in a simple reaction. So in a simple reaction, if I have 1 mole of reactant and exactly it gets converted into 1 mole of the product in a simple chemical reaction. So this we can say that the conversion of reactants into products, the output of the reaction in terms of the yield, right? So that yield is called as chemical yield. You have done many chemical reaction in your MSc, SEM 1, I think SEM 2, there are so many chemical reactions you have conducted. So in that case we are so we actually what we see the conversion of reactants into the products, that is the completion of reaction. If I have 1 mole of the reactant, 1 mole of R I have, and in any chemical reaction for this, if this is thermally induced, so I'm expecting conversion that is a fair yield or excellent yield, that is a 90% of. So the 90% conversion means, for example, if I have 1 gram of reactant I am having, so whatever is in terms of mole, if I can say that, so this is arbitrary value I'm taking. If I have 1 gram of the reactant, so as a 90% yield, how much I'm expecting? I'm expecting the 9.09 grams of the product. Of course, yeah, this is all arbitrary because in the mole the molarity might be different in the products. You understand how to calculate the molarity of the product, of the molecular weight? You understand?
Yes.
Okay.
Yes, ma'am.
So this is the arbitrary value. If I have 1 gram of reactant, so in the product I am getting 0.09 gram of the product. It means that the productivity is 90%. If I have 1 gram of the reactant and the conversion I am getting over here, that is a 1 gram of the product. It means that the conversion is completely 100%. And as the reaction is chemically driven reaction, so I can say that the reaction is this yield is nothing but the chemical yield. Means the yield is obtained by simple chemical reaction. You understand the difference? Why I'm stressing on this particular term, that is a chemical yield? Because the reaction is chemically driven reaction. This is a chemically driven reaction. The difference between chemically driven reaction and the photochemical reaction is, in chemically driven reaction, the reactions are accelerated by the reagent, and that reagent is nothing but a chemical. And in the photochemical reaction, the reagent is nothing but the reagent is H nu. Though we have the reactant also, but it takes for the acceleration of the reaction, it requires some reagent. So in photochemical reaction, we are using H nu as a reagent. Understand? So that's why in a simple chemical reaction, if the reaction is chemically driven or simple chemical we are using in terms of in the form of reagent, and if we have 1 mole of reactant, conversion is 90%. That type of yield is called as a quantum yield. Now let us see what is the meaning of quantum yield. What is the meaning of quantum yield? Now I have this R. So as a reagent, I am using H nu. As a reagent, I am using H nu. So I am getting the first excited state. And this first excited state is converted into the intermediate, and that intermediate is ultimately converted into the product. So this is a general mechanism of the photochemical reaction. This is a general mechanism of photochemical reaction, right? Now this reaction, now if in the what we can say that if the reactions are directly converted into products, this is called as a chemical yield. This is called as, because the formation because the formation of this product is with respect to, this is called as a chemical yield. So this is called as a, why this is called as chemical yield? Because this formation of product is with respect to your chemical or the reactant or the reagent we are using. But the quantum yield is nothing but the quantum yield, we can say that this is if the reaction is photochemically driven, so H nu is responsible for the conversion of reactants into the product, and this is called as a quantum yield. This is called as a, this you get this point. If the product P is obtained with respect to R, please just look at this arrow I am putting over here. If reactants and the product direct, if the product P is obtained with respect to the reactant, then it is also called as a chemical yield. But if your product is obtained with respect to photon or H nu, then it is called as a quantum yield. ये समझ में आया आपको सबसे पहले? So this H nu is very, very important, which gives you this idea of the quantum yield. Now, in another term, I can say that the quantum yield is it is denoted as a psi, and this psi is nothing but it is the ratio of number of product molecules formed when it absorbs with, it is the ratio of number of product molecules formed with respect to number of photon absorbed. Number of photon absorbed. Now in this case, so you are getting my point. What is the quantum yield? Quantum yield is if this H nu amount of energy is absorbed by the molecule, and how much molecules are formed, how much energy is absorbed by the molecule, how much energy is absorbed by the reactants, and that reactants, so that energy will responsible in the transformation of reactants into the products. So I can say that if R absorb h nu amount of energy and with some intermediates, it is going to form a product. Okay, so if I say that one h nu, one photon, it is absorbed, one photon it is absorbed. As I told you that in the last lecture we have explained the Jablonski diagram. We have explained the Jablonski diagram, and that Jablonski diagram is nothing but the, yes, what is that?
Photophysical change.
Yes, so that photo, so whenever the energy is absorbed by the molecule, no doubt there are certain changes, but uh, not fully the complete conversion of reactant into product, generally not observed in the photochemical reactions. Why? Because the another process is always taken place in the photochemical reaction, and that is nothing but the photophysical reactions also, or photophysical changes, I can say that. So that those reactions are the photophysical changes, right? So though it absorbs some amount of energy, but that doesn't mean that it can convert the complete reactants into the product. So the scenario I can write over here that so this is somehow h nu amount of energy is absorbed by the molecule. Now in this case, the h nu amount of energy is absorbed by the molecule. So a series of transition will take place, or series of reactant, series of formation of reactants or excited molecule will take place. So R absorb h nu amount of energy, and you will get a excited state. It may involve the singlet state and the triplet state. So I can say that. So please remember that always write as zero, which is nothing but the ground state, and this might be a singlet state and the triplet state. And further, they are converted into I1 and I2, and final there will be a product. So no doubt there is a conversion of excited state into the intermediate state, from first intermediate state to second intermediate state. There is a possibility of formation of even a third intermediate state. We never know how many changes can be developed over here. So the other possibility is if R if R absorb h nu amount of energy, it gets excited from the singlet state to triplet state. The first possibility is it can be come back to the original state. It can be come back to R. This is your first possibility. Now another possibility I can explain you that R absorb h nu amount of energy. It undergoes excitation with the singlet state as well as the triplet state. Further, it goes to the intermediate of first intermediate step. Then again, it will come back to your reactor. Third possibility is again R absorbs h nu amount of energy. It undergoes excitation. It attains singlet state. It attains triplet state. It undergoes I1. It undergoes I2, and again it will be back to R. And the fourth possibility, or the last possibility, I can say that. So R absorb h nu amount of energy. It undergoes R excitation, which is nothing but the singlet state as well as the triplet state. Again, there is another change, that is the formation of intermediates I1, I1 to I2, and there will be a final formation of product. Formation of product. Okay, so arbitrary value, if I can take, if I take that, if I am using one photon for this reaction, okay, I am inducing this, I am irradiating this molecule with the one photon. Okay, So one photon if I am taking, and I can see how many series are going over there. I can observe that this is the first change, right? This is the second change, this is the third change, and this is the fourth change. So there is a possibility, so there are n number permutations and combinations we can observe over here, that the reactants are converted into the products, but simultaneous there will be a various possibilities. The possibilities are very much there, because uh, the photochemical reactions are not very what we can say, as these reactions are they form all the free radicals in the reactions. So we can say that the reactions are not very effective unless and until we have to follow certain rules and regulations. But if the general mechanism, I can say that if I am using h photon, one photon for the reaction, in that case I will get various changes. I'll get a series of changes. I can get a series of changes, and those series are, the first is r to r star, and again r. This is first change I can get, r to r dash. Then in this case we have I1, and again it will be back to R. Then the third possibly I can observe over here, that R to R dash, then I1, sorry, I1, then I2, then it will be back. And the last and least the possibility will be R dash to I1 to I2 and to the P. So first case can be happened, the second step can be happened, third can be happen, and even the fourth can be happen. And in the last stage, the four steps can be possible. You are getting my point. Now, in this case, which part of the photon is, because ultimately what we don't want these changes, we don't want first case, we don't want the second change, we don't want the third change, but we want the fourth change, right? So if I am providing one photon of energy, so how much energy is available for the conversion of reactant into product, right? So that is nothing but the quantum yield. So if I can say that I'm getting four changes over here. For example, if I'm providing h new amount of energy, and I'm getting four types of changes, as we can see that. Now you're getting my point. Please let me know.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay. So that if I'm providing h new amount of energy, so I'm expecting four different changes over here. So if I have four different changes, so out of one photon, how much energy for the first change is nothing but the 0.025. So I'm dividing this energy into four fractions, right? So part of the one photon is utilized to conversion of R star to R. So this partial conversion is nothing but the, I can say that 0.25 is utilized for the conversion of R to R star to R. Then another fragment is utilized to convert R star to I1 to R. 0 to, sorry, 25 is utilized R star to I1 to I2 to R. And the last thing is the point R star, I1, I2, and the P. So ultimate goal is the conversion of reactants into the products, right? but how much energy is absorbed, how much energy is absorbed and how much effectively that energy is capable to convert reactants into the product. In this case, we have seen that only 0.025 energy is productive energy, or the what we can say the exact one-fourth of the photon has been utilized for the conversion of the reactants into the products, right? So in that case, total quantum yield, I can say that, so in any, so here we can say that the quantum yield is nothing but the any number. It is a any number. So that it doesn't mean that if I am supplying one photon of energy and that complete energy is absorbed by the molecule, and because of this one photon, this is responsible for the conversion. Here we have seen that I am bombarding the molecule with one h nu, but what I observe that only one-fourth of the energy has been utilized or useful for us to convert reactants into the product. In one or what we can say three-fourth of the energy is we have not used for the reaction, or we can say that the three-fourth of the energy is useless for the photochemical reaction, because this has been used for the various changes, or this has been used for the photophysical changes, right? And only 0.05 or one-fourth of amount of energy is has bringing a photochemical change over here, while three-fourth of energy is not useful for us, so it is unable to convert the reactants into the products, while one-fourth of the photochemical reaction is capable of, right? So only one-fourth of energy is absorbed by the molecule, and it is forming the reactants into the product. So that if I can say that this is a psi can be any number, or I can say that psi is equal to 1, or psi is always greater than 1, or psi is less than 1. Now what is the meaning of that? So this is fine that psi is any number, but the meaning of this that psi, if psi is equal to 1, it means that the ratio we obtained over here, what is that this thing, yes, this is a somehow we have the what we can say the, okay, so this is I'm using this ratio over here, that okay, so how much amount of energy, or the what is the meaning of psi is equal to 1, the another term is psi is greater than 1, and the third term is psi is less than 1. Now if I say that number of product molecules are formed, if I am supplying two photons and two molecules are the quantum yield is, or what we can say the two molecules are formed in the product, so the expected quantum yield is 1. So 1 means 100% conversion. You are getting my point? If I am using 2 moles of the reactants, so what exactly I am expecting the 2 moles of product, right? So if I am applying a 2 photons, so in the this equation I can put the number of product molecules formed. कितने मॉलिक्यूल्स फॉर्म हुए हैं, मोल्स फॉर्म हुए हैं, या इन टर्म्स ऑफ मॉलिक्यूल्स n is equal to 2. Okay, and how many photons are absorbed over here? 2 photons I am giving. So here 2 by 2 is equal to 1, which means that there is a 100% conversion. So this is a highly efficient conversion, which is practically not possible, which is practically not feasible. Adis parentheses. Right? So number of you are getting my point. If psi is equal to 1 means जितने photons हम लोग दे रहे हैं और जितने reactants के conversion है, like reactants are 1 mole. If I am taking 1 mole of reactant, so 1 mole is converted into 1 mole of the product. And in that case, if I take 1 mole of if 1 photon of the as a reagent, so that conversion is 100% if your psi is equal to 1. So in some cases, if psi is greater than 1, so this is the reaction of polymerization. This is the reaction of polymerization. So what does it mean? That if I am inducing one photon, so if I am taking the one photon, and at a time, if 10 molecules are if the 10 molecules are formed, it means that it is a polymerization. Now, in many cases, in general, if I take that zero point 0.5, if I am inducing H nu is 1, I am getting 0.5. It means that psi is less than 1. Now, this always we observed over here that efficiency is never is equal to 1. It is always less than 1. Why? Because we have seen in this reaction. Now look at this reaction. So though we have this conversion, but it is a partial conversion. So partly the part of energy has been wasted in first case, in the first stage, the partially it is wasted in the second stage, then in the third stage. So only 0.25 energy has been utilized in the formation of the fourth case, that is the reactants into the products. It means that though we are inducing one photon, but only 0.5 moles or the molecules are formed, right? Yani 50% of efficiency, we can say that. So it can be extend from the 50% to 60% if 0.6 has been there. So it is what we can say that it is 0.6. So it can be 0.7, it can be 0.8. But actually in practically these reactions are feasible. Practically these reactions are possible. Now you understand the significance of the quantum yield.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So how to calculate the quantum yield? Quantum yield is calculated in terms of the actinometer. Okay. This is actinometer. इसके ऊपर के problems अगर आप चाहोगे तो next class में हम ले सकते हैं, but to my opinion, we can switch over to the Norrish Type I reaction. And the product efficiency, I can say that in terms of product efficiency. So if I take R, and this is I am bombarding with H nu, so R as the overall representation of the product, this is nothing but the I am expressing a product efficiency, right? R H nu will give you R excited state. That is the second step will be the formation of I, that is nothing but the intermediate, and the intermediate will give you P. Another possibility I can express over here, that it can give you I dash, or it will be back to, it will give you P dash. Another possibility is I can be converted into sorry, I can be converted into I double dash, and you will get the product. Now overall productivity. Now here R is if we forget these steps, and I can directly write, if R is bombarded by or irradiated by H nu, so how much products? Now these are all products, please remember, these are all products. So R is converted into P, R is converted into P dash, and R is converted into P double dash, or double dagger, we can say that. It means that, and which one is the desired product? Which one is the desired product? You are getting my point. So even these possibilities are we can see over here. So R is converted into P, R is converted into P dash, or R is converted into P double dash. But which one is the desired product? That depends how much percentage, because we in all reactions, why we conduct reaction, we always want a desired product. Okay, so some in this case P might be a desired product, and rest of the products are they can be a byproducts, right? Or in some cases P single dagger is your desired product, and P dash, double dagger, and P, they may not be. So in this case, how you can calculate the quantum yield based on these products? So because ultimately there will be a conversion, there is no photophysical reaction we can observe here. Have you seen any photophysical reaction? No, there is no photophysical reaction, but all reactions are photochemically allowed. These are all photochemically allowed reactions. Reaction हो गई है, and we got different products, P P dash and P double dash. Okay, so in this case, how can you calculate a quantum yield for many products? For many products, so I can write as a this thing. So total total psi is represented over here. So number of P divided by number of H nu absorbed, okay, plus, now ये मॉलिक्यूल इसमें ऑलरेडी है तो मैं बार बार नहीं लिखूंगी. So number of P dash obtained by absorbing number of H nu absorbed plus number of P divided by number of H nu absorbed. So this is a quantum yield of a photochemical reaction. In that case, more than one products are obtained. So it is the addition of all ratios, we get a total quantum yield. You got my point?
Yes, ma'am.
Yes.
समझ में आया? This is a simple quantum yield I can obtain over here. So overall एक बात आपको ध्यान रखनी है, always quantum in the chemical reaction, actual chemical reactions, photochemical reactions, actual photochemical reactions, psi is never 1. It is always less than 1. Always less than 1. Remember, Okay, so in actual photochemical reactions, psi is always less than 1. Now, one thing you must understand that if I say that the reaction is photochemical, it means that all reactions are um, they form free radicals. They form,
Free radical.
no reaction will be proceed via formation of like carbocation, carbanion. No, the reaction proceeds via formation of free radicals. Please remember. Okay, as the reaction is photochemical reaction, means any light, if we are using any light source, it bombards on the R, there is an excitation, and that excitation will give you a free radical. समझ में आई बात? Yes.
Ma'am. Yes, ma'am.
Okay, so let
Yes,
us
ma'am.
have the next topic, that is a Norrish type 1 reaction. I think this is understood.
Yes.
Shall I rub this?
Yes, ma'am. Yes, ma'am.
Okay. So I'm deleting this thing. Now the next most important, now here actually we have started um, the topics in the photochemical reaction, and that is nothing but the various name reactions which are performed in the um, photochemical reactions. And the first reaction I can say that there is a Norrish type 1 reaction. Norrish type 1 reaction. Now in this reaction, what is the significance of this reaction? The first significance is that this reaction is photochemically induced. So let us see some important characteristics. Before that, I can define this reaction. Now, what is the definition of this Norrish type 1 reaction? This is the acyclic saturated, right? Acyclic saturated carbonyl compound which undergoes an initial cleavage of carbon and the carbon of carbonyl compound, right? Carbon of carbonyl functionality, I can say that functionality. Cleavage of carbon and the carbon of the carbonyl functionality bond, and which gives you a which gives to give, that is a acyl and alkyl free radical, alkyl radicals. So this reaction is known as Norrish type 1 reaction. अब इसको explain करते हैं. That is a Norrish type 1 reaction. Now here acyclic saturated carbonyl compound. तो इसकी अगर बात करते हैं, पहले हम लोग एक मॉलिक्यूल देखते हैं, देन विल सी द हाउ देयर इज अ पॉसिबिलिटी ऑफ द क्लीवेज. सबसे पहले acyclic saturated carbonyl compound. Let us see which compound. We can take a simple acetone. So first thing, I can put a carbonyl compound over here. Why we have chosen this substrate? Why we have chosen this substrate? Yes. Why we have chosen this substrate, that is a carbonyl compound. In transitions, how many types of transitions we have seen? There is, here we can get that how many types of transition we have: n electrons, we have pi electrons, we have
Sigma
sigma
electron.
electrons.
Sigma.
So sigma to sigma dash, sigma to sigma
Sigma.
pi star, then
N
uh,
to pi star.
n to pi star, then n to pi star लास्ट में लेते हैं हम लोग, then pi to sigma
Pi to
star,
sigma star.
then n to sigma star,
N to sigma star.
then n
N to
to
pi star.
pi star, and pi to pi star. Okay, so when we have this absorption spectra, what we have observed that only these two bands are very strong and the rest of they require a lot of energy. So this type of transition will take place from UV visible region. Rest of the transition required energy from the X-ray gamma, or more than that. Okay, so these type of transitions required much more amount of energy, and that is not available from the UV visible region. So that's why these transitions are not possible in general. So what type of transitions are we are expecting over here? Either there is an n-pi transition, or there is a pi transition. Okay, now that's why we have selected this substrate, and this is nothing but a special name reaction which is done by the Norrish, and which is a Norrish type of reaction. So let us okay, we'll focus the molecule. That is a simple molecule, acyclic saturated. Okay, acyclic, so we don't need any cyclic molecule right now. We are not using any cyclic molecules. So acyclic, now this is a simple ketone I am taking over here, and which undergoes, so please just go through. The first condition is acyclic saturated ketone, that is I have taken this simple ketone over here, which undergoes initial, that is the first, I can say that. Okay, so this is the first change I am doing over here. Okay, so this molecule is bombarded by H nu, or irradiated by H nu. So this is initially at the ground state, and always please remember that you, whenever you write any mechanism, so it undergoes the first excitation state, and it is denoted as S1. So again there will be a, so please remember that Jablonski diagram, whenever there is an excitation, so there are how many types of possibilities? S0 to, here in this case I am using this type of transitions. Okay, so this represents the absorption of energy. Okay, absorption of the photon. याद करो मैंने उस दिन आपको पढ़ाया था. You have that diagram.
Yes, ma'am.
Yes. Yes, ma'am.
Then the second possibility is S1 to T1. T1 means triplet state, जो मैंने बताया. So this type of, this is called as a absorption, and when there is a jumping of S1 to T1, what is this called as? Inter
Interconversion.
crossing,
Internal.
ISC.
Inter
Yeah,
intersystem
internal
crossing.
inter-system crossing, or internal system crossing,
Crossing.
whatever, which is called as a ISC. So ISC takes place over here, and which gives you the, there is no breaking or there is no conversion, there is only excitation of the electron. So S1 to T1. Okay, so you represent this thing as like this. Now the second condition, as I told you, that the initial cleavage of the carbon of the carbonyl functionality. Now you here you have how many connections over here? Here you have one connection and the two second connection, है ना? ये कार्बोनिल है, इसके साथ ये जुड़ा हुआ है, और ये कार्बोनिल है, इसके साथ ये जुड़ा हुआ है. So there is a alpha cleavage. There is a there is alpha cleavage मैं आपको बाद में explain करूंगी. There is a bond breaking in between carbon and the carbon of the another. So I can take, if I, so this is a symmetrical molecule, so I can take any type of breaking where we can obtain. Now let us see, as I told you that the reaction is always proceed through the formation of free radicals. So third point is now initial cleavage of carbon of, initial cleavage मैंने कर दिया यहाँ पे. Have you got it? So there is an initial cleavage over here, and the alkyl radicals and acyl radicals will form. So let us have the formation of, this is my acyl radical and this is a alkyl radical. Okay, now the alkyl and acyl radicals are formed. This reaction is called as the Norrish type I reaction. Now the most important thing is there is a alpha cleavage. What is the meaning of that alpha cleavage? What is the meaning of that alpha cleavage? The meaning is that if I have if I have this type of molecule, for example, so I can take any type of cleavage over. So next to the alpha, so this is your carbonyl compound, this is a functional group, and next to the alpha position, so this is your alpha, or this is your alpha 1 or alpha 2. So either you can have the bond between C and alpha 1 C, and the C double bond O. Another possibility is bond between C alpha 2 and the double bond O. Here it is not possible. यहाँ पर नहीं होगा. Only there is a alpha cleavage. So can we again we can have the another definition. So this is Norrish type I reaction is nothing but the alpha cleavage of the acyclic saturated carbonyl compound, which forms the acyl and the alkyl radical. And after the disproportionation reaction or the termination of the reaction, of course you will get the different products, right? But the main characteristics to be remembered over here, the first characteristic is it requires acyclic saturated carbonyl compounds. In some cases we have also observed the Norrish type I reaction, but the acyclic saturated carbonyl compound, then there is a alpha cleavage takes place over here, and in the third step there is a formation of the free radicals, which one is the one which is nothing but the acyl radical, another one is the alkyl radical. Now here I can write some characteristics over here. So let us see some how you can define the Norrish type I. If generally ऐसे questions आते नहीं है, they just give you some reactions and you have to write down the mechanism. But before that, you must know the some characteristics of the Norrish type I reaction. So the key points to be remembered over here. Characteristics of Norrish type I reaction. Now, what are the characteristics? Let us see one by one. As I have already explained you, but let us see by one by one. Now, the first characteristic is it is done by the homolysis. The homolysis. Now, what is the meaning of homolysis? Homolysis occurs between the C double bond O and the adjacent or alpha carbon, right? Means if we have this, so the home bond कैसे बनता है? Because of the two electrons, right? So if I take homolysis, I am getting, so there is a retention of, right? There is a retention of two electrons with the separate molecule. So this is a homolysis. And the second characteristics is this is also called as a photofragmentation or photochemical fragmentation. This is also called as a photochemical fragmentation. फ्रेगमेंटेशन मतलब टुकड़े टुकड़े हो जाते हैं, ठीक है? ये जो मॉलिक्यूल है ये कट हो जाता है at different points, it gets cut and you will get the different fragments. And the third important point is the, अब इसको इंड्यूस करने के लिए किस टाइप का ट्रांजिशन इज इफेक्टिव ट्रांजिशन? There are two types of transitions. We can see that there are n-pi transitions and the pi-pi transition. Here, the n-pi transition brings about the photochemical change. So this n-pi transition brings the transformation, or right. So the energy available from this type of transition will give you a photolytic. Now the meaning of photolytic means there is a fragmentation. There is a photolytic fragmentations. Now once the photolytic fragmentation takes place by alpha cleavage, so photolytic fragmentations by alpha cleavage, it takes place by alpha cleavage. This reaction is called as a primary photochemical reaction. The first thing, that is the breaking of these, whatever we have seen over here. So this is nothing but the primary. So this change, so formation of two radicals. समझ में आई बात? Formation of two radicals is nothing but the primary photochemical reaction. Okay, this is a primary photochemical reaction. So in the characteristics, what is the photolytic fragmentations by alpha cleavage gives you a primary photochemical reactions. Means the formation of radicals. Now once radicals are formed, as we know that every reaction has initiation, batao, initiation,
Termination.
propagation and the
Termination.
termination. Now initiation we have done, and the propagation part, once they have the there is a formation of radical over here in the first primary photochemical reaction, then it starts propagating. And after that you will get the termination. Now here again there will, if there is a primary reaction, there is also a secondary photochemical reaction also, right? So for primary photochemical secondary is followed by the secondary photochemical reaction is followed by the primary photochemical reaction. Okay, primary secondary photochemical reaction. So I can represent over here, that is a primary photochemical reaction gives you secondary photochemical reaction, and there will be a termination. You got it? So the formation of primary and secondary is the part of nothing but the propagation of the reaction. Now, in the detail, if we say that there is a one condition where when the reaction is carried out in a gas phase at 100 degrees Celsius, this primary photochemical process is followed by the secondary. Now we have different how the reactions are terminated. Now let us see one by one how it is terminated over here. Now it is said that if we have a primary reaction over here, primary photochemical reaction, after propagation we are getting a secondary photochemical reaction or process. Secondary now there are here how the reaction is terminated. Here there are three possibilities. So three possibilities, I can say that. The first possibility is, as I told you, that if the reaction is carried out by in the gas phase, in the gas, see this the reaction in all reactions, the reaction conditions are very important. So whenever there is in the question, if this reaction condition have been put on this arrow, it means that the first they have given you the reactants in a gaseous phase at the 100 degrees Celsius. So there is a 100% there will be a decarboxylation. There is a decarboxylation. If there is an abstraction of hydrogen, if there is a abstraction of hydrogen, alpha hydrogen, I can say that, then there will be a disproportionation. And the another thing is, now there is a possibility of abstraction of alpha hydrogen, and the third thing is abstraction, the that is a intermolecular abstraction of hydrogen. Abstraction of hydrogen. Now, what is the difference between abstraction of alpha hydrogen and abstraction of hydrogen? That is an intermolecular abstraction of H. We'll see by explaining the example. Let us see. यहाँ तक समझ में आई बात सबको? Yes.
Yes, ma'am.
This is a simple. Now, by taking example, the idea will be, you will get the clear cut idea about when we have some reaction mechanism over here. Okay, so now I take this simple acetone, and this is H nu. This is at the ground state. Now please remember, always write your mechanism in this fashion only. So what I should write? So acetone at S1 excited state, then there will be a ISC, right? So CH3 will be converted into, the acetone will be converted into the triplet state. Now here the general mechanism. Now first apply first condition, that is the first condition will be a alpha cleavage. What is that? So from where I should break? So Here I can break the molecule and there is a formation of acyl radical as well as the alkyl radical. So this is a acyl radical. Now this process is nothing but the primary photochemical reaction. Now we know that in the Norrish type 1 we have the alpha cleavage, and the second characteristics now apply over here. The primary photochemical reaction undergoes secondary. Now there are some secondary changes. Now what are those secondary changes over here? The first, if I'm putting some, like if my reactants they are in a gas phase, and I'm applying 100 degrees Celsius. So what is the condition I'm getting over here? That is the decarboxylation, right? In the decarboxylation, so I have the substrate. See, I am the complete these two reactants. Sorry, these two intermediates. I am writing again over here to explaining the decarboxylation. Now, in the decarboxylation, again, what is happening? So CH3, the formation of CH3 plus CO, which is nothing but the evaporation of the carbon monoxide. And what are the products? What are the other? As I told you that when there is a R, you will get R dash. Then you will also get I1. You will also get I2 or I3, whatever. Right? So here I am getting another I2. और ये ऐसे कैसे नीचे आ जाएगा? Now in the termination. So now here I am proceeding toward the termination of the reaction. So how it is terminated? I have the alkyl radical from the acyl radical and the another alkyl radical. They there is a formation of bond between this thing. So formation of simple alkanes. Okay, so this is the one possibility. Now another possibility is abstraction of alpha hydrogen, जो मैंने आपको explain किया इसके पहले. That is the abstraction of alpha hydrogen. Now where do I get alpha hydrogen? So here, so I have these two, okay, acyl plus this, so I am representing as it is. Now here a little bit I will modify this moiety, that because I need to show the alpha. Okay, so I can write it as a, so there is a abstraction of alpha hydrogen. So this radical abstracts the okay. So this radical abstracts the alpha hydrogen. Alpha hydrogen means the carbon having the alpha carbon having alpha hydrogen. You got it? So this is your alpha carbon. Now this alpha carbon is abstracted by this radical, and ultimately you will get the formation of ketene. This is called as a ketene, and you will again get the formation of methane. Okay, so this is the another possibility. This is called as a ketene. This is called as a ketene. And the third possibility is the intermolecular. Okay, so there is a intermolecular. अब यहाँ पर हमारे पास इंटरमोलिकुलर ट्रांसफॉर्मेशन के लिए जगह नहीं है, बिकॉज वी हैव दिस रेडिकल. ओके, CH3 रेडिकल. अगर इसकी जगह दूसरी मोइटी होती, विल एक्सप्लेन बाय For example, if this is like this, अगर इसकी जगह हम लोग CH2CH3 लेते हैं तो यू आर गेटिंग माई पॉइंट. CH3 जो है वो इट इज वेरी हाईली स्टेबल रेडिकल, so it will not give it any hydrogen. But if we consider this, so instead of this, if I take in this case, in that case only we have intermolecular abstraction of hydrogen. Okay, so if I am taking this moiety, so what will be my radicals? The radicals will be like this. And CH2CH3. ठीक है, मैंने थोड़ा सबस्ट्रेट चेंज किया है टू शो यू द इंटरमोलिकुलर एब्स्ट्रैक्शन ऑफ हाइड्रोजन. नाउ for the sake of intermolecular abstraction, so I am just modifying this moiety a little bit, that okay, so I'm doing it like this, I'm drawing it like this. Okay, so this one of the hydrogen is abstracted by the, so this has the carbonyl compounds have a very strong tendency to abstract the protons, so that abstraction will give you the aldehydes and the alkenes अब यहाँ से होता है या यहाँ से होता है, we'll let us see that in many cases it is absorbed by the like this from this center. Okay, so there is again there will be a intermolecular rearrangement will take place over here, and the formation of alkenes. So the formation of aldehydes and the alkenes over here. Now, so you got this mechanism, Norrish type I.
Yes, ma'am.
You got this?
Yes.
Yes.
Yes, ma'am.
Okay. So this Norrish type I reaction will let us see. Let us summarize reaction. That is under homolysis, there is a cleavage between carbon of the carbonyl compound and the alpha carbon. So ultimately it is called, the alpha cleavage is very, very important. That is a number one characteristics and extremely important characteristics of the Norrish type I is the alpha cleavage takes place over here, which gives you the acyl radical and the alkyl radical, and this is nothing but called as a primary photochemical reactions. These primary photochemical reactions undergo secondary photochemical reactions, and these secondary photochemical reactions terminate the reaction into various products. So there are three possibilities. First possibility is the decarboxylation, where if the reaction is carried out in the gaseous phase at 100°C, so there is definitely a decarboxylation takes place over here, which gives you the carbon monoxide and the alkane. So the decarboxylation in Norrish type I reaction will give you the carbon monoxide and the alkanes. So these are the products which are formed in the first type of termination reaction. Now in the second type of reaction, the possibility is alpha abstraction, where the reaction is terminated and it gives you the ketenes and the alkanes. लोअर अल्केन्स जिसको हम बोलेंगे, है ना, दिस इज कॉल्ड एज लोअर अल्केन्स। और यहां पर हमें हाइयर अल्केन्स मिलते हैं as compared to this reaction. And the third possibility is intermolecular abstraction of proton. Intermolecular abstraction of proton. इसमें हमें क्या मिलेगा? We are having the products as aldehydes and alkenes. Now these are the general reactions. So by the next class is on Wednesday, right? So we'll see some examples, and mostly the examples will from setnet examination, gate examination, jam examination. So we'll see one by one various examples based on Norrish type 1 reaction. ये समझ में आया आपको कि कैसे रिएक्शन होती है, तो ही हम आगे जाके जा पाएंगे.
Yes, ma'am.
Yes, ma'am. So shall I give you one example?
Yes, ma'am.
Yes, ma'am. Okay. Now one thing you have to remember that if I have this type of substrate, so I forgot to tell you. So CH3, CH2, C double bond O, CH3. Now, if this is the substrate, how many alpha carbons are there?
2.
2. This is alpha 1. I can say that this is alpha 2. So where there will be, there are two possibilities of the cleavage, alpha cleavage. Pehli possibility, cleavage between C and alpha 1. So this is the first possibility. This is the first possibility. And what is the second possibility? Second possibility is alpha 2 will be your, so this is a second possibility. तो आप बताएंगे कि कहाँ पर ये रिएक्शन होती है, कौन सी पॉसिबिलिटी है, केस 1 पॉसिबल है या केस 2 पॉसिबल है, मैं दूसरा और एक बताओ.
फर्स्ट वन में डीकार्बोक्सिलेशन और सेकंड वाला जो है उसमें इंटरमॉलिक्यूलर एब्स्ट्रैक्शन.
नहीं, वो चीज नहीं बोलना, पहले अल्फा क्लीवेज कहाँ पर, वो तुम बहुत आगे चले गए अभी.
केस 1.
Yes, one.
केस 1 होगा या केस 2?
One.
देखो मैंने दूसरा एग्जांपल भी लिया है, उसमें भी आप बताओ मुझे कि क्या होगा. इस पर भी देखो अभी. पिछली केमिस्ट्री भूल गए ना सब, इसलिए कुछ नहीं याद आता लोगों को. हाँ.
Yes, ma'am.
So whenever we have any type of intermediates, what we have to remember that regarding the if there is any formation of intermediate अगर होता है तो हम किस चीज पे पहले फोकस करते हैं, उसकी स्टेबिलिटी पे फोकस करते हैं, राइट. सो इन दिस केस लेट अस सी द स्टेबिलिटी. इसमें फर्स्ट केस में क्या फॉर्म हो रहा है, कौन सा रेडिकल फॉर्म हो रहा है, दिस रेडिकल इज अ प्राइमरी रेडिकल. और यहाँ पे क्या हो रहा है, सेकेंडरी रेडिकल. So if we see the stability of the radical, so tertiary is more stable than the secondary than primary. तो बताइए अभी.
Second.
So this second case is feasible over here. Why? Whenever we see the formation of intermediate, we also must see the possibility of the stability. We must also look look at this point of view that what is the stability of the that particular intermediate. Okay, just because हमने करना है ऐसा नहीं करना है आपने. We have to also focus the stability of the intermediate. Now in this case also let me know which one is the pathway. First pathway cut होगा या second pathway cut होगा. Here we are getting secondary. Here we are getting the tertiary.
Tertiary.
So path 2 is feasible path, not this one. समझ में आया? Yes.
Yes.
So in this way, you cannot
Yes, ma'am.
even just simply break this point. You cannot even simply break this point. Why you are breaking these points, the alpha cleavage, there should be some justification, and that justification is nothing but depends on the stability of the intermediates, right? And that's why you are breaking this point and not breaking this point. You understand? So whenever we have any formation of intermediates, we have also look at this factor, that is a stability of factor of the intermediates, and that's why in both cases the path 2 is feasible rather than the path 1. You got it? Let us see one example and we'll see the next. चलो सॉल्व करके देखो ये कैसे है. Now now in the symmetrical molecule, you need not worry about any point you can break, you will get the proper fragmentation. Okay, चलो करो रिएक्शन. ये देखो मैंने रिएक्शन कंडीशंस प्रोवाइड की है. सबसे पहले क्या करना है हमें, पहले व्हाट यू हैव टू राइट,
Alpha cleavage. S1.
इसके बगैर करोगे तो आधे मार्क्स कट जाएंगे, समझे? Now, so there will be alpha cleavage. तो कहाँ, यहां से भी करो यहां से भी करो तो भी कोई फर्क नहीं पड़ेगा क्योंकि द मॉलिक्यूल इज सिमेट्रिकल, राइट? अब इसको थोड़ा सा इलेबोरेट करेंगे क्या? ये कौन है?
मोनोऑक्साइड.
और ये कौन है?
अल्काइल फ्री रेडिकल.
टर्शियरी. ठीक है. Now I have already given you the conditions. Now which type of now this is primary photochemical reaction takes place over here. अब सेकेंडरी में आपको क्या देखना है? I have given you these options. So इसमें एक ही पॉसिबिलिटी है, that possibility is nothing but the
Decarboxylation.
decarboxylation is only possible because I have given you the condition. Understand? So decarboxylation again.
Loss of carbon monoxide.
Yes, there is a liberation of. Now what are the condition? Carbon monoxide is liberated. ठीक है. Now there is a termination. टर्मिनेशन में क्या कर रहा है? एक रेडिकल जो है जो असिड ग्रुप से निकल के आया है, सॉरी है ना। असेंबल ग्रुप से एक रेडिकल निकला हुआ है, ये रेडिकल, और ऑलरेडी ये वाला रेडिकल। अब फॉर एग्जाम्पल दिस इज ए रेडिकल, दिस इज बी रेडिकल, एंड डीकार्बोक्सिलेशन से जनरेट हुआ हुआ ए डैश रेडिकल. So this is your A dash radical, and let's have a B radical which is generated in the primary photochemical reaction. So this is a B radical. So the dimerization takes place, and you will get the formation of
alkane.
higher alkanes. ठीक है, तो ये आपको जो अल्टीमेट प्रोडक्ट मिला है वो ये है. तो एक जो फ्री रेडिकल है वो हमें प्राइमरी फोटोकेमिकल रिएक्शन में मिलता है, ये वाला, और दूसरा जो हमें रेडिकल मिलता है वो सेकेंडरी प्रोसेस में मिलता है. दिस इज अ सेकेंडरी केमिकल प्रोसेस, photochemical, of course, photochemical process, right? So one radical from primary photochemical reaction and another radical from secondary photochemical reaction, they combine together, and the dimerization takes place, and there is a formation of carbon monoxide and the higher alkanes. Okay, so guys, let us stop over here. A lot of time I have taken actually. I need to finish this topic because वन स्टेज में मैकेनिज्म एक्सप्लेन करना ज्यादा ठीक अच्छा रहता है, राइट? सो